Hi and Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will present our project. We are from Group 3 and bring a topic related to auto cleaning solar panel. Now, okay, now we will proceed to the next slide. Okay, okay, for this slides, outline the key topic we are be presenting today. The first, we have a content introduction. Second, a problem statement, objective, system overview and component, how it works. And six, this technologies design. Seven, diagram and process explanation. And lastly, conclusion. Okay. Now we will to go the introduction. I pass my from my phone.
Good day, doctor. I'm Shankari Sivaraju. Today, I would like to explain about auto clean solar panel system. Solar energy is today considered one of the most important renewable resources. On the other hand, photovoltaic panels lose up to 20% of their efficiency owing to the accumulation of dirt, dust, and other debris that covers those panels. Current means of cleaning are usually labor intensive, expensive, and inefficient for a large scale installation or those that are otherwise inaccessible. The auto clean solar system with wipers, an innovating automated answer to such a challenge. In other words, this is achieved by a system equipment with sensor and smart control. Clean and efficient solar panels involve almost no human intervention and may foster very soon the application of renewable energies in economical cleaner. These are the problem statement with challenges faced by solar panels. First, accumulation of dirt, dust and pollutant reduces efficiency. Regions with high dust level or pollution faces significant challenges. Second, manual cleaning in labor intensive, which include costly cost and impractical for large scale installation. And then third is traditional cleaning methods that rely heavily of water, increasing environment impact. Our innovation is to develop automated water safe solution to maintain solar panels cleanliness, improve system efficiency, and promote the widespread adoption of renewable energy. And to be honest, for now our project we have done it in a small house owning solar system. In future we will believe that it will come in a big scale. Okay, next we will go to the objective of our project. Auto clean solar system is to design an auto clean solar panel system that operate remotely and automatically, develop a cost effective and time efficient cleaning method for solar panels, and then third is validate the system's performance and reliability through comprehensive testing and experimentation. Nandri.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hassan bin Muhammad Al-Bantra. I will explain about system overview and component. And the second topic, I will explain about how our component work. So from the overview, the system work by cleaning the dust in the solar panel. The sensor will detect the dust and clean the solar panel. Uh, our product have a two mode, which is auto and manual mode. We are using several component. The important component in our project has five, which is servo motor, work as a hand to clean the solar panel. Arduino Mega as a microcontroller to control the process. Optical dust sensor work to detect the dust. Relay, two channel relay module to control LED light, LED indicator, and motor pump. And lastly, our component is a motor pump itself, uh, to dispense water to a solar panel. Next, how is it work? First at all, to use our model, we must insert the plug top into the socket outlet. Then, turn on the main switch. To know the presence of AC and DC current, we can press a testing switch, which press it with. If white LED indicator turn on, this has a presence of AC and DC current. To start the process, we can press a green one button and it will set in automatic mode. To stop the process, we can press the red one button and it will stop the process. The sensor will read the presence of the dust. To set the manual mode, we can press the black button and the yellow indicator will turn on. In manual mode, the model will work even if there is no dust present. Okay, that's all from me. I will.
Assalamualaikum, nama saya Muhammad Afiq. Bahagian saya adalah Technical Design. Ini merupakan layout design yang telah kami layout design projek yang telah kami buat. Kat sini ada empat view layout. View daripada atas, view daripada depan, view daripada bawah dan view daripada tepi. Projek kami ni dibagi pada dua, iaitu bahagian indoor dan bahagian outdoor. Pada bahagian indoor mempunyai control unit, indicator, switch, power unit dan water tank dan supply. Dan bahagian outdoor pula mempunyai media of execution, switch, sensor, motor, pump dan hand cleaner. Ya ini adalah schematic diagram untuk Arduino Mega dan ini pula adalah sambungan di dalam software untuk Arduino Mega.
Assalamualaikum. My name is Riyadinata Karmawira bin Suzali. I will explain about the system flowchart. So there are some symbols that represent its function. Oval as start or stop, arrows as connector, parallelogram as input or output, rectangle as process, diamond as decision. So it starts with the power supply. Power supply on, system on, LED red on, LED green off. When the start or stop button press, there are some events happen.
Either it will work manually by sensor or giving feedback of its error. Okay. As you can see, option A represent as work manually, option B represent as work by sensor, but if the relay light is off and LED red on, LED green off, it means that there is an error. This block diagram represents a closed loop control system where the system adjusts its output based on feedback to achieve the desired performance. Here's a breakdown of its component. So the input is the desired value or set point that the system aims to achieve. It enters the system and is compared to the feedback signal to determine any deviation or error. And then comparison. The circle with X represents the error detector. It compares the input with the feedback signal and calculates the error. And then microcontroller, the controller receives the error signal and decides how to adjust the system to minimize the error. And then process, the process is the system being controlled. It performs the actual operation or task. The controller's signal drives the process to achieve the desired output. So the output is the result of the process. It should ideally match the input or desired value. And then the feedback elements, sensor. The feedback element measures the actual output of the system and sends it back to the error detector. This feedback ensures the system continuously adjusts to maintain the desired output. So overall function, the input is compared with the feedback to detect errors. The controller process the error and sends corrective actions to the process. The sensor monitors the output and sends it back as feedback for comparison, closing the loop.
Now I will present the result of the analysis before. Before I present it, let's me into myself first. Okay, my name is Harris Irfan. Now I will to go to my presentation. For this result analysis, we can form the difference between the two conditions of the peninsula. The first peninsula before cleaning, and the second peninsula after cleaning. From from there we can make a graph from the data according to the efficiency of the peninsula and to absorb light and the difference in the power reduced. Okay, let's go to see the graph. Okay, this is the graph for the measure of the duty solar panel measure before solar panel cleaning and the second graph measure on the cleaning solar panel. Okay, we have R two curve showing voltage value under two distinct conditions. The first curve represents the energy produced by an onwash solar panel recording between 10 a.m. until 12 p.m. The second graph recorded during the same time frame represents the energy reduced after the solar panel effluent has been cleaned. As several there is a noticeable difference in the energy value under the first two conditions. The detail of these different will be explained in the next slide. This slide focuses on presenting the value of both scenario and the corresponding result. Okay, now you can see the two graph. The first graph for the duty peninsula before cleaning, and second graph to after cleaning peninsula. They are different voltage. Okay, next I can present about the comparison and comparison between two peninsula condition. Okay, okay now I can present about the comparison of the peninsula condition. Uh, the two curve I compare for the mid one curve. The curve above the compare the voltage value generated by solar panel before and after clean. Measure at a half-hour interval from 10 a.m. until 12 p.m. It actually showed that the cleaner solar panel consistently produce high voltage across all time points, highlighting the impact of the cleaning on the energy efficiency. Okay, now you can see the graph for the blue uh, for before solar panel clean and the orange graph after the solar panel clean. You can see the voltage increase. Okay, that's all for me. Now I will to pass my friend.
So, as for conclusion, whether by advocating for policies, investing in clean technologies, or using renewable energy in our homes, together we can make a significant impact. Thank you.